The 2001 relative velocity question, part B. We have a speed of an airplane in still air is 160. It flies in a straight line from P to Q and back again. Point Q is north of P. Okay, so we have Q north of P, Q and P. And throughout the journey, there's a wind blowing from the southwest at 32 kilometers an hour. And we're given the time for the whole journey to be 5. And we're looking for distance. So we have time, we're looking for distance, so we'll be looking for speed here as well. So the wind is coming from the southwest. It's coming in this direction here from the southwest, so we can connect it to P or Q. If we connect it to Q, if we imagine as an x-axis, we can have the southwest wind coming in here, and it would continue obviously in that way. That would be 45. So this would be 45 in here. This would be 45. We can have our plane flying in this direction here to try and get up to Q with the wind affecting it. So this is going to be the velocity of the plane relative to the wind going in the straight line. The plane has to go kind of slightly to the left. That's the velocity of the plane over here. And the velocity of the wind is going up in this direction here. So let's see what we have here. We have the plane is 160 down here, kilometers an hour. The wind is 32 over here. So looks like we have enough there to get another angle inside that triangle. So let's just draw this triangle out again. I've got 32. I have my 45-degree angle inside it. My 160 for my plane, so I can definitely get this angle down here. Let's label it A, it's the first one we're looking for. So we're going to have 32 over the sine of A is equal to 160 over the sine of 45. So cross multiplying here, we're going to get 32 sine 45, or 32 over root 2, 32 by 1 over root 2. And that's going to be equal to 160 sine A. So if I leave the sine A there and divide by 160, the 160 down here, we're going to get sine A to be 1 over 5 root 2. And the inverse sine of 1 over 5 root 2. It's going to give a small angle, 8.13 degrees. That's A. So we're going to need the velocity of plane relative to the wind. We're going to need the speed of this eventually. So we will need this angle opposite it. We'll call it B. So this angle B is going to be equal to 180 minus 45, which is 135, minus 8.3, which is 125, plus 1.87, 126.87 degrees for the angle B. So now if we look at the plane coming back down in the opposite direction, still have Q and P. So the wind is coming in from the south. If we look at it going towards P, the plane will need to fly out in this direction here. So the velocity of the plane is 160 going down in this direction. The wind is coming up in this direction. That's 32. And the angles we have here, the wind is coming at a 45-degree angle. So we imagine this is our x-axis here. We have a 90 and a 45, so this one in here is going to be 135, and that's opposite to 160, so we can get the angle opposite to 32. So we can say 160 over the sine of 135 is equal to 32 over the sine of, we've had an A and a B, let's call it C and D. The sine of C, so 32 sine 135 is going to be equal to 160 sine C, so divide by 160, and that will give us the sine of C, and this works out to be 1 over 5, and sine of 135 is root 2 as well, 1 over root 2. So it looks like it's the same size angle here. We're going to get definitely 1 over 5 root 2 again is equal to the sine of C. So therefore C is equal to 8.13 degrees. We already have a 135 in there, so D is going to be equal to 135, sorry, yeah, well, plus 8.13. And we'll need to take that away from 180, so 180 minus 143.13 is going to leave at 36.87 degrees for D. So now I can get the velocity of the plane relative to the wind in both cases. This one here, just keep the triangles in view. So we go back to blue. So on the left hand side, we have the velocity of the plane relative to the wind over the sine of the angle opposite, which was B, 126.87. It's going to be equal to, and we can use any of the other ones, 32 over the sine of A, 32 over sine 8.13, or you could use 160 over sine 45. So 32 sine 126.87 is going to be equal to sine of 8.13 by the velocity of the plane relative to the wind. So just divide by your sine of 8.13. We'll get the velocity of the plane relative to the wind to be 181.02. That'll be in kilometers an hour. And on the return journey, we're going to get over this side the velocity of the plane relative to the wind over the sine of the angle opposite, which will be D down here, over the sine of 36.87 will be equal to one of the other sides, 32 over the sine of C, sine of 8.13. So 32 sine 36.87 will be equal to the velocity of the plane relative to the wind by the sine of 8.13. And if you type this into your calculator, you get the velocity of the plane relative to the wind on the way back down. 32 sine 36.87, that's equal to 135.76 kilometers an hour. And we're told the total journey is this 5 hours. So we have speed now, so we're looking at the distance up and down is the same. So what we can say here is that time is equal to distance over speed. So the 5 hours will be equal to the distance over speeds combined. The distance is the same. So 5 is going to be equal to the first distance up divided by the speed, 181.02, plus the distance down divided by the speed on the way down, 135.76. So if we just do a simple algebraic fraction and do it maybe in one step, if I'm going to multiply the two things on the bottom, and then cross multiply on top, I'm going to get 135.76d plus 181.02d will be equal to 5. So cross multiplying, I'm going to get 5 by 181.02 by 135.76 will be equal to that amount of d's. So if I factor out my d, I will be adding the two things together that I'll need to divide across by, 135.76 plus 181.02. So that's just doing it in one step instead of using the calculator loads of times. So in the calculator, this is giving me 387.89 kilometers. And we asked for the total journey, we're asked for the distance from P to Q, and give your answer to the nearest kilometer. The nearest kilometer, the distance from P to Q is going to be 388 kilometers. Bit of work involved in part B in 2001.